So tell me if this story sounds familiar. You just got a prototype of your LLM application up and running, and you run your first output, and you're waiting, and you're waiting, and you're waiting, and then suddenly, bam, big wall of text. Not exactly a smooth user experience now, is it? However, if you're using the Hugging Face libraries, there is a better solution, and it is called text or token streaming. Usually it's called text streaming, but it can go by both names. So in this video, we're going to go over text streaming in the Hugging Face ecosystem. Luckily, Hugging Face provides us with very easy to use built-in text streamers, so we can go ahead and make our applications feel a little bit more responsive and kind of improve the user experience. So let's go ahead and start off fresh here. Get rid of the model and the tokenizer, and let's go ahead and load up the model of your choice. Now, this technique that I'm going to show you is completely model agnostic. I'm using the latest Gemma 7b IT model from Google, but you can use this for any model that Hugging Face supports. Whether it's Llama 2, Dragon Plus, whatever you want to use, that's fine. So let's go ahead and start off by loading up the model. Unfortunately, there's no way to speed this part up. All right, perfect. So let's go ahead and dive right into the solution. So what we're going to do is from the Transformers library, we are going to import TextStreamer. Now, in the Hugging Face ecosystem, all you really need to do is you need to create a TextStreamer object, which is just an object that is going to accept tokens as the model is generating them, and just pass this streamer into the model.generate function whenever you pass it in the rest of the inputs. So at that point behind the scenes, Hugging Face is going to take that streamer, and anytime the model generates a new token, it's just going to pass it into that streamer, and it's going to do whatever it's going to do with it. Now, this first one that we're going to go over, the text streamer, this one is just going to print out the text as it's being generated to standard out, which makes it perfect for prototyping in a notebook or in a console environment setting. So let's go ahead and create our streamer. So we're going to have a text streamer object. And we're going to pass in the tokenizer, so it knows how to decode the tokens whenever it gets them. And we're going to have it, we're actually going to include the prompt. Now, if you wanted to, you could have it skip the prompt entirely, so it just returns the new text that that is being generated by the model, but that is up to you. I'm going to go ahead and keep it here, just so we can see the entire output all at once. And we can also pass in skip special tokens, and I'm actually going to enable this one, but that option again is up to you whether you want to see those tokens, whether you're doing some debugging stuff, or if you just want to skip it and just have the human readable text with no additional frills added to it. So now we need a prompt here. Let's go ahead and go with an open-ended one. There we go. That's a nice open-ended prompt. So let's go ahead and get the input IDs, and we're going to pass our prompt into the tokenizer. And now that we have our prompt converted into tokens, we actually need to pass this into our model. So all of this is pretty standard. If you've worked with LLMs and Hugging Face before, this is all going to seem very familiar to you. And let's give it plenty of tokens to work with here. That should be good. And now here's where we pass in our streamer, as we want to specify this as the new text streamer object that we created before. And so now anytime the model generates a new token, it's going to pass it into that streamer, just as we mentioned before. And now we should be good to run, except I have an error. Why do I have an, inputs ID. Make sure you are spelling all of your arguments correctly. And just for my sanity, I'm going to print a finished down here so that we know that the model has completed its generation. So let's go ahead and run this new generate call with our streamer and see what happens. So there you go. You can see that it is slowly outputting all the text to standard out, and we have a much nicer user experience. We're not staring at a blank screen. So if we were the end user, we can actually start reading this and starting to digest what the model is actually saying. So there we go. The model has finished, and it's important to note that we still have all the tokens available in the output of the model.generate. So if we say result is equal to tokenizer.decode, and we pass in our output, if I can spell. My fingers are all over the place today. And as you can see here, the output from the model still has all the tokens, so we can still do with the output whatever we want. It's just that the streamer object let us see the output as it was being generated. But we still have all the text ready that we can process it programmatically however we want. So the TextStreamer is good for debugging LLM applications either at the notebook level or at the console level, but it's not really realistic or really helpful to just print the output to standard out. We want to do a little bit more with it, and the TextStreamer is kind of limited in that regard and what we can actually do. A much more useful streamer that Hugging Face actually provides is the TextIteratorStreamer. Now, what this streamer does is instead of outputting the text straight to standard out, it actually stores it in an iterator object so we can actually retrieve the text inside of a loop and then do whatever we want with that text going forward. So it gives us a lot more freedom to actually take that text and do stuff with it programmatically as it's being generated rather than just print it out to standard out. So let's go ahead and create one of these objects. And we're going to go ahead and use the same prompt as before. So one thing about using the TextIteratorStreamer, which might add a little bit of complexity to your applications, is it needs to run in 2 threads. So you're going to need one thread that is calling generate on the model, meaning that it's generating new tokens and actually placing those tokens in the iterator. And then you need another thread to actually call that iterator to actually do stuff with the tokens. But not to worry, in Python, using threads is pretty straightforward. I'm not going to go into too many details, but I'll show you how to create a thread that will call the model.generate, and that should be enough to get you started with this. So we need to create a thread object, and we're going to give it a target, and this is going to be the function that it calls whenever it starts the thread. And this is going to be the model.generate function. Now, we're not calling the function, we're just passing a reference to the function so that it knows what to call when it's in its turn to run. Now we need to specify the arguments that we're going to pass into it. And this is just going to be a dictionary object. And don't forget to pass in our streamer object. And I did that inputs IDs again. So now that the thread has been created, let's go ahead and start it. So now this will spin up a parallel thread that's going to call model.generate with the arguments that we passed into it. The moment we do that, the model is going to start generating new tokens based on our prompt. So now in this thread, our thread, we're actually going to start iterating on our text streamer and actually doing stuff with that text. So for this example, I'm actually going to save it to a file. And we're going to print it to console out as well. So let's say for new text and streamer. So that's how we use the iterator object in a loop. So every time that we go through this loop, we're going to grab the new text from the streamer until it sends the end of list signal, in which case it will terminate this loop. So now that we have the new text, let's go ahead and print it out. And we don't want to print a new line, so we're just going to redefine what we print at the end. And we're going to write the text to our file. Just like that. And so outside of our loop, what we're going to do is we're going to make sure we close our file. Always make sure you close any file that you open and call thread.join just to make sure we don't have any dangling threads at the end. Okay, let's go ahead and run this code and see how well it does. So as you can see, both threads are working as expected. We have the generator thread generating new tokens, and we have our thread in our notebook that's actually outputting the tokens to standard out and to our file. So there we go. We can see that both threads have finished processing, and we can also see that not only has the text been output to standard out, but it's also been output to our file just as we expected. So between those two streamers, you can prototype pretty much any feature that requires text streaming in your LLM applications. But let's say you wanted to take it a step farther. You didn't want to use the built-in ones, and you had a really complex process that you kind of wanted to hide away in its own class. It is possible to subclass the streamer's object. So if you just go to the Hugging Face GitHub, you can go to the streamers.py, and I'll link this file down below. But you can see the definition of the base streamer, the text streamer, and the iterator streamer. So you can get an idea of how these streamers work and subclass them to fit your own processes or your own use case. But that's a little bit beyond this very simple introductory video, but this is how you can get a reference if you wanted to subclass these streamer objects yourself and create your own. And that is the basics of how to use streamers in your LLM applications to make it a little bit of a smoother experience for your end users. Hope you enjoyed the video, and I hope you learned something. And if there's something that you would like to know about using LLMs or the Hugging Face ecosystem or any sort of coding topic at all, please let me know down below. I would love to hear some suggestions, and maybe I'll cover it in a future video. Thank you all so much for watching, and happy coding!